Question number 6. So I've got a series of um, absolute value equations and inequalities. Now remember this one thing. There's nothing you can do until the absolute value itself is isolated on one side. So here I'm going to cross over this division by -3. I will have a multiplication by -3. And -15 times -3 is positive 45. And then here I'm going to do 2 crossing over at once. I'm going to cross over +3, which is going to be -3, and then divided by -2. 45 minus 3 is 42. Divided by -2 is -21. Now the absolute value itself is isolated on one side of the equation. And then, in that case scenario, whenever you have a negative number on the other side, you need to ask yourself the question, is it always possible or never possible? The absolute value is necessarily a positive value, and a positive value cannot be equal to a negative value. So it doesn't matter what you input for x, this will never be true. So you can conclude directly that there is no solution, therefore x belongs to the empty set. For b, I'm going to do the same thing. And here, because it is an inequality, you have to be careful. You need each time that you cross over a multiplication or a division with a negative number, which will be the case twice, you need to flip the inequality. So let's do that. Let's cross over this division by -3. So I'm going to flip the sign. It's still 45. Then I'm going to cross over the addition of 3 and the multiplication by -2. I will therefore have absolute value of 2x plus 1. So I'm going to flip back the inequality because I'm crossing over a multiplication by a negative number. I will still have -21. Now, in that case, a positive value will always be greater than a negative value. So this equation right here will always be true no matter what you plug in for x. So x can be any value. It belongs to the set of real numbers. For this one, there's one little detail, is that now I made this coefficient 2 positive. So I will have 2 times absolute value of 2x plus 1 plus 3 less than or equal to 45. And then I'm going to subtract 3 and divide by 2. I will have positive 21. So see, in the two other cases, I had a negative value on the other side. So, and here too. So I have this case scenario. Either it's never possible, like here, there's no solution, or it's always the case, like here. In that case, I don't have this problem. Now remember, Once you have an absolute value equations or inequality, this is when and only then that you can break it down, break it up into two possible equations. First, or inequality in that case. First, I remove the bars, and then for the second inequality, I will remove the bars and flip everything else. But when I have less than, which is the case here, I can expect to have a compound inequality, and the flipping of the inequality will occur by writing it onto the other side. And therefore, I will have 2x, which will be between negative 21 minus 1, which is negative 22, and 21 minus 1, which is 20. See, I'm doing the exact same thing, but on both sides. And finally, x will be greater than negative 22 divided by 2, which is negative 11, but less than 20 divided by 2, which is 10. And here it says explicitly to express the solution using interval notation. So I will have x belongs to the following interval, negative 11, 10. And I'm using brackets because, so let me choose another color here. I'm using brackets because those two boundaries are included. I've got less than or equal to. Pay attention to that. And that's it. Good luck.